So guys, let's go ahead and see how the story of lines inside the circle goes. All right, we're going to start with one of the very fun stories, not really that complicated. So I'm gonna draw a nice big circle here. Maybe that's too big, maybe just about there. And then I'm going to bring this down so that you can see it. And there's a point B here, as you can see, and I'm going to draw another point so that I can have a chord. And there, so I'm going to draw a chord. This will be chord BC or chord CB, whichever way you wanna look at it. And after that, I'm going to have a point. Okay, so actually, instead of having a point, let me just draw the line because that's what the theorem says. So guys, the theorem actually says a line that is drawn from center and happens to be perpendicular meaning at 90 degrees to the chord, actually bisects the chord. So let me quickly check if my angle here is indeed 90 degrees. 90.05, I don't think that's too bad. That's fine. Of course, the error here is being caused by the thickness of the line and stuff like that. And you can see I used some sort of freehand to draw this. So now let's see if this is true. I'm going to measure the distance of this line, 4.53, so we should expect DB or BD to be around the same measure. So we can see, roughly speaking, this is 4.5 and that's 4.5. Okay, that's we can see the theorem is kind of satisfied. And as I said, accuracy here is being affected by the fact that I'm using freehand, so I am not really able to get to the correct exact measures right as I need to. So I'll leave it at 90.05. That 0.5 degrees is very significant, as you can see. However, rounding off to one decimal place, we can see we have exactly the same measures. So that's what the theorem says, guys. Let us write this nicely for you so that you can understand it. So this is what we're gonna say. I want to write it in words so that you can also make sense out of what we have just done here. And of course, maybe I should just get rid of that background and have that, right? So what this thing is saying is that, I want to close this thing actually, because it's disturbing me. Yeah. So what this thing is saying is, okay, so let's call this theorem 1. A line drawn from the center of a circle, of course, perpendicular to a chord. Now, I'm a mathematician, I'll be very lazy, so this means perpendicular to a chord. The result is that it bisects the chord. So this is how the theorems work. You've got a statement or a condition, and you have a result. In this case, our condition is that this line must be perpendicular to a chord. The result is that it will bisect the chord. In other words, this section of the chord is equal to that section of the chord. We will get to the proof of this thing later on. As I said, I just want you to get used to this and play around these theorems for now. Let us look at what we call the converse of a theorem. A converse refers to the reverse. Okay, so what does the reverse say? If we do this thing in reverse, I hope you can follow with me. It will then say, well, a line drawn from center or from the center of a circle, okay, to the midpoint of a chord. So that thing D here is a midpoint, okay, is perpendicular to the chord. So you can always use this converse. You are welcome to use it. And the point with the converse is that, well, if you have a same line and they tell you that this line actually is drawn to the midpoint of a chord, then you can conclude that, well, that line then is at right angles with that chord. That's what the converse is saying. It is the reverse, guys. So the converse says, well, you know that the line bisects a chord, then you must know that it is perpendicular to a chord. A line, by the way, drawn from the center, not just any line. And the theorem, original theorem says, well, any line from the center that happens to be perpendicular to a chord, that line actually bisects the chord. So that's what the theorem says. Regarding examples, guys, I will take a few examples for you when I have kind of covered all the theorems, not really all theorems that relate to lines that are in a circle. When I have done that, I will definitely take some nice examples for you. So for now, let us look at the second theorem that we are going to discuss in this journey.